Hi everyone, welcome to the dev chat with some of the Avalanche developers, and so I have with me Patrick O'Grady, Stephen Butolf, and Aaron Buchwald with me, and we're going to be talking about everything Avalanche, all of the current stuff, and of course the big thing on everyone's minds, which is inscriptions and what they mean for us and what they mean for Avalanche. So before we kick it off and go into a sort of a more general format, I want to say a couple of things. The very first thing I want to say is we hear you. I know that the fees spiked. I am very, very well aware of what's happening on the chain. So that happens, and it's designed to happen. So there are two things to say about this. One, the chain works flawlessly, and that's a huge thing to be able to say. There are many other chains that keeled over. Ours is kicking away. And at some point, I was seeing a combined TPS of about 10,000 transactions per second, 9,600 something. So on the C chain alone, we were getting about 977 TPS at its peak. So sustained is like 600 TPS. So these are incredibly high numbers, and we did well through the spikes. Now, none of us are happy with where the fees are right now. And a lot of the discussion today is going to center around sort of some of the thoughts that the devs have about what we can do about that. The second thing I want to tell you is to reassure you that we're on it, that we're thinking through the solutions, and to remind you that this is the team that brought you the most innovation in blockchains since Bitcoin. So what did we bring you? We brought you all sorts of things. You know, you're talking to the person who found the biggest known flaw in Bitcoin, the person who ended up calling the DAO hack before it happened, the people who brought you the fastest layer twos, the people who brought you the fastest consensus protocol, the people who brought you the world's best bridges and the world's most secure trading platforms. So we have a great brain trust, and we've all been quite busy, of course, working on all sorts of things related to subnets, related to subnet communication. But of course, recently we turned all of our attention to inscriptions, and so let's get into it. Let's talk about inscriptions. Let's talk about what they are, what they're sort of doing at the fundamental level, and what might be some of the things that one might be able to do to shield regular users from the load and congestion that inscriptions pose. So to that end, I'm going to kick it off with Patrick. Maybe Patrick, you want to start us off? Tell us a little bit about inscriptions, where they come from, what they do.
Yeah, this isn't something that I think it's taken a lot of chains by storm, which is exciting and also interesting at the same time. It's funny because I think a lot of teams and a lot of projects were optimizing for ways to scale execution capacity, but weren't really aware or the concerned about scaling some of the raw data bandwidth capacity. So for example, like in the world of L2s, right? Like it's great when you can have like a bunch of execution happen off chain and then prove that on chain. But at least in the L2 world, you still like bring the data on chain because you want someone else to be able to like re-execute and verify those inputs if they need to take over the rollup or like regenerate state at some point. But that architecture makes sense when you have a lot of off-chain execution you're trying to scale, not when you're trying to scale the data aspect of it. And so, I think I wrote a thread a few days ago about talking about like perceived incremental value of interaction. Some people I think just got really pissed. So like, gas prices went up, like all this stuff is on chain. Some people call it spam. And they're like, everything's broken. But what's happening, right, is like there's a group of people that seem to think like there's a perceived incremental value of these transactions that's far above whatever the fee is, and they're just issuing transactions that do that. What is the change responsibility? Well, it doesn't have any ability to interpret perceived incremental value of me or you, and that's a good thing. That's what keeps it like censorship resistant and neutral. But the issue is when there's huge gaps in what people think the perceived incremental value is and then what other people do, but also just the absolute value of the fees for interaction, especially if people look for something lower. And so a lot of the conversations we've had are, what are the different changes that could be introduced to the Avalanche network that we could propose, via the ACP process that, could alleviate at least the absolute transaction value fee on the primary network. So We've had a lot of conversations about that. I think we can definitely get to many of those things right now. But I think it first makes sense to cover exactly what is the inscriptions right now that are currently on the C chain. So maybe Aaron, you want to explain what people are doing right now?
Sure. So the way that I like to explain this is it all starts off with this original. Are you saying something? You're muted if you are.
Just keep going.
Just go ahead, Aaron.
Okay. Yeah, so what the inscriptions are basically doing is they're making use of posting call data on chain that they're not actually using, as Patrick mentioned, any of the execution capacity of the chain whatsoever. So all that they're actually doing is posting some data on chain to be interpreted entirely off chain. And so this might sound very similar to L2s. And so the main difference between this idea and what most layer 2s are doing is that there is no expectation that there is some sort of bridging functionality to move assets from the existing L1 to some sort of other execution context where that execution is moved to. In this case, all that it's doing is sequencing some amount of data in order to interpret it in some off-chain context, and then relying on that off-chain interpreter, whether you use some indexer or a separate system entirely, in order to come out to some result as to what that data means, how that gets interpreted, whether that be these are NFTs that you own, or I've transferred my NFT from point A to point B. So it's entirely removing the execution capacity and using it purely for this posting of call data that gets sequenced someplace. So what these things typically do is that they also essentially depend on the API server services or some indexer that's indexing that chain where they're being posted in order to serve those transactions, in order to access that call data. And this is sort of taken into account as a part of their trust model and their security model, is that these chains will continue to operate and will continue to be able to serve these transactions where they have the call data that they actually rely on. So there's nothing unique about these transactions that makes it so that they can be introspected or that they should be punished or anything along those lines. From this perspective of the chain, as Patrick pointed out, this is just an alternative use case of how to use it, of how to use that capacity on chain, where it's using only the bandwidth and it's using significantly less of the features that we typically think about as how people are using smart contracts on blockchains, which typically when people think about this, they're using the execution capacity directly. There's some number of state modifications. There's some amount of access to that atomic state. And in this case, they're not using any of that whatsoever. And they've essentially decided that the value of posting that call data on chain is high enough that they're willing to pay this amount in order to post those transactions. That's pretty much how these inscriptions are working. They have this off-chain component. Yeah, not sure what you want to go into next, Patrick.
I mean, I think the joke there is, I was telling someone the other day is like, everyone spent all this time on like crazy execution capacity and capability and everything. It was like, why did we try so hard? Like, we could have just had data, like consensus over bytes, and like we would have, But it's funny in terms of just thinking about it from that lens. So Steven, I'm sure there's some stuff you want to get in here as well.
So I actually so I don't know if this is too much of a topic change, but I kind of want to talk about like how fees work on the C chain a little bit, and how that interplays in with kind of inscriptions. So the way that blockchain fees work, at least for the C chain, this is the same with Ethereum and some other chains as well, is it's a very kind of simple supply and demand curve. So if anyone's taken like some economics classes, they'll be used to like some kind of like supply curve that looks, like something like maybe, increasing supply, whatever, like this. And then you have some demand curve that like, as you're willing to pay kind of like more, you're essentially going to like tick up and intersect with the supply curve at like a higher point. In blockchain, the supply is a constant determined by kind of the hardware requirements of the validator set. So for the C chain and for mainnet Ethereum and for all of the EVM based chains, there's essentially just a number that gets put into the chain, which is what is the target gas. On the C chain, it's per block. For the Ethereum mainnet, it's per block, and for the C chain, it's on a rolling window of 10 seconds. But that number is just kind of like how much load are we willing to put through the network over time. And that's just a fixed number, only changes during hard forks, which correspond with either perhaps performance improvements or changes in the validator hardware requirements. The dynamic part of this is the demand. So Demand is purely based off of users. And so if there's some NFT drop or, an inscriptions mint or whatever, the demand might increase a lot. And so people are essentially, that demand curve shifts out. And so essentially the point that demand curve intersects with the supply curve ends up being at a higher price. Essentially people are bidding to try to get that block space, and the price ends up spiking. So in this world of supply and demand, where we're essentially trying to guarantee the stability of the network, the only way to get fees to go down is either being more granular on the types of supply. So maybe like a single supply curve isn't perfect, because we're just kind of mapping this all into what we call gas on an EVM. Maybe we should be separating things out between bandwidth usage, compute, storage, and pricing those things separately. Or just shifting this curve out further and saying, we're going to increase the hardware requirements, or maybe we've worked on like some really awesome performance things, so we can just kind of shift this curve out. Those are really the two kind of like concrete ways of causing fees to decrease, because you're increasing the supply, and for the same demand curve, the points intersect at a cheaper price, and so everyone's kind of happier. They get their transactions in for cheaper. So that's how all of these kind of like on-chain auctions work. And we're really kind of taking both of those ways of kind of making that fee lower, and working on both of them. So I don't want to hog it. I don't know if maybe Patrick, you want to talk a bit about the separating the supply into multiple curves with multidimensional fees.
No. Before we get into smart stuff, let's talk a little bit about the sort of the simplest approach, which is increasing the hardware requirements of the validators. So we have been running with the same hardware requirements for a very long time. I think Patrick probably has the best historical grasp on this, and he can chime in.
It's simple, unchanged.
Unchanged ever since launch, right? And at launch, we targeted an outdated server. That's essentially what we targeted. We wanted anybody and everybody to be able to join. And so if you had a little server slab lying around, or if you had an old computer at home under your desk in your den, you should be able to, we felt, join the network. So this is not what other chains are doing. There are many chains where the hardware requirements are so high that it essentially requires professional setup and serious amounts of resource commitment from anybody running a validator. So we could easily, and I would suggest that we probably should, explore this path. We were happy with the participation a few years ago, and computers have only gotten faster since then. So if we were happy then we should be even happier now, and it's time to probably up the requirements and allow the chain to run hotter, essentially, to be able to clear more transactions per second. So that's something at our disposal, and that doesn't really require all that much, and it does require something from our validators and from our community, which is that they bring in bigger, heftier machines to participate with their validators. But it doesn't require any changes to the technology, and it's a well-trodden path that other people have explored, and that's essentially been one of the main ways that they got their scalability. So ours has been always software smarts first, and not throwing hardware at the problem. But this is a good way to, I think, take a first cut. So that's something that's in our pocket that's already come out of this discussion. So Patrick, you were going to go into sort of more.
I think we had some hesitation in the past on doing more of that when the requirement for the primary network to validate it and synchronize it was a requirement to run a subnet. But if ACP 13 is adopted, then I think it opens up a very different story where like the primary network, has its own, high throughput scaling story that doesn't impact, subnets at all. And then subnets can set their own resource requirements, assuming the P chain remains somewhat manageable. And I think in that architecture, we would still, or the community should definitely consider like limiting more of the P chain aspect of it still, because that's what all subnets will still need to operate, but then maybe open up some of the floodgates on the C chain if people are running more advanced hardware or, storing more state in NVMe drives or like whatever the validator requirements could be. Now, this is not, just to reiterate, not something to just take lightly, right? Like usually the more expensive a validator is to run, it obviously has inverse effects on decentralization of the network. So like if you have to have a really high throughput like bandwidth card, or like, you have to have all these crazy server components, typically that plays out in, well, less people validate. So this is a great ACP topic. I think that would be really interesting to debate openly about like what the pros and cons are, but really it's defining, I think, like what the identity of Avalanche is. Is it trying to just say, we're never going to go above 8 cores, 16 gigs of RAM, like we'll fit in that box, and anything else, the fees go up. And that's what's going on. Compared to some other networks that have more capacity, like the minimum requirements are dramatically higher than that. And like, if I think that's a good point to bring up, which is like, if that's all we want to do, like, well, we could scale the resources directly just with that. But to bring it back, there are two components here. One is like scaling, or I'd say maybe three components. We've touched on one of the three. One is just have more resources at your disposal. The second one is somehow update or refactor the software to make it more efficient and be able to handle just more load with the same resources. And the third one is actually, assuming you have tons of capacity, how do you actually meter it or meter usage to avoid like reliability issues? So on the second point, we're working on basically a proposal for like some decoupled state machine replication stuff that should come out early next year. That goes into some of the lower level ideas we have for, really pushing the throughput or capacity of the same hardware. I'm not going to go into that much now. Goon always told me a joke, which is like in academia, you never want to like let people see too much of your work before you put it out yourself, because then people can kind of jump around and jump ahead of it. But we are working actively on it, and something that will come out pretty soon around like how we think this is a good way to scale agnostically any virtual machine. But the other problem you have to deal with is that even if you do scale that capacity, how you're actually metering it. So a lot of our work on that has gone into something we call multidimensional fees. So multidimensional fees are a topic that's been discussed for some amount of time here. I'm not the person that came up with it, nor do I claim to be. I think some people I actually know from Bain Crypto wrote a really nice paper on it. I think it's somewhere in my Twitter. You can take a look at it. I'll try and find it and drop in the comments. But the idea here is most blockchains today are single resource priced, or like single unit priced. So in Ethereum or Bitcoin or Solana or whatever, there's like a unit for fees. In EVM, we call that gas. Gas, the single unit representation, there's a price for bytes in a transaction. There's a price for storing stuff in state. There's a price for deploying a contract. There's a price for everything. And somehow the virtual machine designer is forced to come up with some relationship between these units, which are totally unrelated, right? Like the amount of CPU you have is completely unrelated from the amount of RAM you have, and completely unrelated from the amount of bandwidth you have. But you as a VM designer are forced to set some relationship between them. And so if you want to modify that relationship underneath like a single gas limit cost, you basically open up more interaction of your most constrained resource. So you need to be very careful. So some people have said, well, there's two easy suggestions, right? Like we'll just increase the cost of call data, or just like increase the gas limit. Then it fixes the problem. I don't think it's as easy as that, right? So if you just increase the gas limit on the block, sure, that increases like the amount of data you can include based on the call data gas cost, but it also dramatically increases the amount of state someone could write in a single block, which can cause reliability issues on the chain itself. Similarly, if you were to say, hey, maybe I'll just decrease the bandwidth cost because that'll increase my capacity. Well, if you open up that world, then you can now store more data there, but then in relationship to the other unit mechanisms, your gas, you basically can't uniformly restrict the max amount of that, even if you change the price. So now by changing the price, you just mean now you can put more in there, and like trying to maximize that and put that together in a framework that fits clear resource constraints is really difficult. So we believe the right way to do it is to apply multidimensional fees to resources, and so have unique resource consumption metrics and metering per type of resource. So in a world of inscriptions, for example, that's a very bandwidth heavy thing. It doesn't really weigh much on the CPU side. It doesn't really weigh much on like what we'd call like state growth, because it's not in state, it's in blocks that can be pruned. And so the important thing is really just the bandwidth consumption. And the problem is, because we're forcing ourselves to relate bandwidth usage with like state access, we're driving up the price for all interactions, even though that's not the case. So let's say even in our world right now with Avalanche validators, there's probably some latent bandwidth available. So if we just wanted to increase the capacity of bandwidth isolated, that would increase the capacity for actually running these types of transactions through without opening the network up to like a state manipulation attack or state bloat. And so I think like the lowest hanging fruit that actually is generic and practical for this case is not repricing or like changing different gas codes, but actually is taking a different view of how capacity is metered on the network. And then as we do that, also work on actually just increasing the capacity generally. They're not indistinguishable things, right? Like if you just threw a bunch of extra CPU at it and you had the same gas mechanism, you're going to create problems for yourself. So like they're not substitutable. We really need to pursue both. And fortunately, we have been pursuing both for some time. We've been working on the Hyper SDK for the last year and a half or so, and that has more or less been our test bed for all sorts of innovations and changes we can bring to virtual machines across Avalanche. And so multi-dimensional fees in particular are something that we implemented 9 months ago or so, testing out a lot of these concepts. And outside of it just being really cool to watch the charts of the different resource prices as you mess with it, it was a really interesting way to increase the throughput under like the same gas price. But again, that's only to a point. You still have to increase that raw capacity because it increases the amount of aggregate burn or like fee payment that needs to happen to keep something at the same mid price, which changes significantly like the underlying economics of the action. And so, yeah. So the way I view it is increasing capacity. You got to do it either through underlying hardware requirement changes or via more efficient software. And then even if you have capacity, you can't get away from more efficiently or intelligently metering usage of that capacity unless you increase all constrained resource caps directly symmetrically, which is, I think, very difficult to do.
I think you made an interesting point at that point, which is that there is a difference between data being stored on chain in what is called like the active state versus data stored inside of blocks, and that theoretically you can prune blocks. So I think that that's a really interesting kind of topic. So in the Bitcoin world, people are adamant that you must keep kind of the full chain and everyone needs to be able to fully re-execute the full chain. And so they limit the block space and the size accordingly, kind of with their vision to always be able to fully execute stuff. There are some other chains that don't do this.
Yeah.
So as an example, Solana very actively deletes old block data from their validators. So they basically only keep, some certain size of historical blocks on disk, right? As far as inscriptions, the reason inscriptions are relatively cheap compared to a normal ERC20 mint or NFT drop is because they aren't actually storing anything in the active state. They're just using that block space, and they're using the fact that validators keep those blocks around as a way of storing that data for them, kind of almost for free, right? So it's a very interesting question on whether or not there is a mispricing for blockchains that keep that historical block state rather than actively pruning old blocks. So it gets kind of into an interesting question of like, what are the security assumptions that people expect from blockchains? Like, is it okay to delete those historical blocks? Like, at what frequency? So I think that's a really interesting question that we as a community probably need to talk about. I know I have very strong opinions on this that I've talked to some people on the call about. I'm not necessarily going to push them right now, but yeah.
I think and then to answer specifically, I forgot to wrap up my point around like, is this the new normal for fees? Is this the target for fees? Is there any hope to bring fees down? So as a community, I think the outcry or like outpour of support has said, no, we'd strongly not prefer to keep fees at this level, which is not necessarily like that may sound funny to you, but like in other communities, there is a goal to like increase transaction fee burn or revenue to a point that it aids the security budget and compensates miners for participation or producers for participation. So as a community, we should be very clear about like what our intention is. Now there's a difference in that our block reward, like the Avalanche block reward, tends to be much higher than the fee revenue, or at least it used to be. And that's no longer the case with the transaction fee side of it. And so if we wanted, like if there should be some relationship change there, or like trying to codify more clearly like what the view is on fee dynamics, I think that's a great ACP. Like if the goal is to say on the primary network, we should always try to keep fees as low as possible, like basically just above the level of a Sybil or like a DOS attack on the network. Like that'd be a great manifesto, I think, to codify inside of the ACP process. And again, this is not necessarily like a foregone conclusion. There are other networks where there's a purposeful cap on throughput and accept higher fees to increase, like to basically keep validator requirements low, or to compensate for different block rewards. Like you may want to like basically pay people in fees rather than the block reward. So I think like really being clear about the trade-off that the community is pursuing certainly is the right way. I think my opinion is very much minimize fees. I know Goon is pretty clear about like minimize fees. I think Steven,
I think let me just chime in. I think, Patrick, you are being very even-handed and neutral in this discussion as always, and that's awesome to see. But I think the vast majority of the community, I think I speak for them when I say that they would love to see much lower fees. We are at a point in our growth cycle that there is so much more room to grow, and we just can't do that if we go into this mode of let's try to play funny games, try to burn as much of Vox as possible, etc. It's much better to be able to onboard people with low fees. So I will do whatever I can to reduce these spikes. I will do whatever I can. So I will never guarantee that the spikes will go away. They are there by design. When something unexpected happens, the gas prices should spike to keep out the economically less valuable transactions. That's by design. But going forward, this cannot be the new normal. We'll do whatever it takes, whatever is at our disposal. Everything's on the table to reduce the gas prices. I think at least I speak for myself and the people I work with. So I think that's loud and clear from the community. We don't need the ACP process. It would be nice. We can go through the ACP process, but I know the outcome, I think, is going to be an overwhelming majority will be asking for low fees.
One thing to comment on the increasing like hardware requirements. That's definitely possible for some of the kind of resources that we've talked about. So like you can definitely increase, the live state, disk requirements for storage. You can increase how many CPU cores are required, how much RAM is required, bandwidth. But the EVM at some levels is kind of a serial execution environment. So at the end of the day, what actually concretely matters the most for block processing times, at least today, is disk latency. So that is something that you can optimize. You can buy like better hard drives, like in the tail case, maybe we even increase RAM requirements so much that you essentially keep the whole like tree of memory and you just don't have to necessarily touch it. But at some requirements, or at some point, it's that disk latency, and that does become harder to actually require validators to improve. So even if we did say all right, you know what, we're increasing validator requirements, I don't know how much we actually could increase validator requirements without also modifying how the EVM fundamentally executes transactions. So this isn't necessarily something that I increase validator requirements 10x, I can increase the state requirements by 10x, or the space of the blocks by 10x or something. It is still an interesting kind of realm where we actually do need to continue to optimize and be able to fully utilize the resources that nodes have to offer. So it's a complex optimization problem for sure.
So, I mean, I think in terms of like the practical steps, because people are like, you can take away from this conversation, like, sounds great. Like, now what? Like, what is actually going on to like push us forward, right? So, it's pretty clear over the last, I don't know, how long have we been working on Warp and Teleporter? Like over a year, right? Like, the biggest request, the clearest ask of the community has been, subnets are cool, but subnets alone are not cool. Like, make them all connected. And so the vast majority of our resources that would have otherwise been allocated to like pure EVM scaling have been working on Warp and Teleporter support. Now, I think, Aaron, we talked about in the last community call, like the last PR is merged. I think there was like one nit that we changed, but like it's merged. It's been audited 3 times, I think, by like Least Authority, Open Zeppelin, someone else, or Lewis, I think, from Paladin. All have been great and offered, a lot of support on that. But that's done. Like, the ACP is up, and I think before the end of the new year, we hope to release a Docker kind of local network you can run to play around with it. Like, you'll be able to, on your local network, move assets from the C chain to your subnet to other subnets, all natively within Avalanche. Now, that's super cool, right? Like, I was super stoked about that and, everything about that. But like the story around our focus on, single chain performance is obviously the other half. And it's not that we haven't been working on it within the EVM. We've just been focusing on this. On the scaling component, we've been doing that work in the Hyper SDK. And so immediately after the next update, which, I think is going to be called Durango, which includes some different ACPs, the immediate focus is very much going to probably shift to this direction, particularly on the EVM scaling and what can be done to adjust the fee mechanisms. And so, that work is probably kicking off now, obviously, as we talked about in the last week or two, with the hope that we can start to propose meaningful solutions, early into the new year on what can be done, at least earlier capacity related changes. And then after that, like larger, deeper changes around to like actually massively increasing the capacity of the chain. So I think some people also thought, are subnets your cop out for like just not doing more? No, like having a single state space is super useful, and especially in the primary network where like the C chain is like this point of like origin for many people coming into Avalanche and also for liquidity. Like, it's clear that needs to have like a higher level of capacity to be able to support the needs of all the different subnets that are connected to Avalanche. And so I think that there will be a lot of subnets that offer like a potentially much cheaper starting point that have very different values around like validator requirements and like centralization of participants, but that doesn't excuse the need to have like, at least reasonably leveled fees within the primary network itself, which has the majority of validators. Yeah. Good.
So speaking of subnets, I want us to discuss with the community some of the ideas that I've heard thrown around. Let me preface this by saying that this whole inscription game is one of cat and mouse, right? So if you decide, for example, to do X, then the inscriptors or what have you, the inscription community will respond by doing X prime. So it's absolutely essential that we do things that are principled, that are foundational, that go to the core of fixing the problem, and not just a band-aid that works for 10 minutes and then the inscriptors then change their behavior. I think everybody knows Avalanche as the chain that brings the best of science. We don't do silly things. We don't do superficial things. We don't do things for PR value. We do things because they address the core issue. Now, there's some discovery to be done here, because sometimes the things you don't know are on the social plane and not on the technical plane, and so we might have to iterate on the technical side. But let's start with this one proposal, everyone. What about an I chain, an inscription chain, a special subnet dedicated to inscriptions? Why don't we do that? Would that solve the problem?
Good question. I think I'll take it first. I'm sure Steven and Aaron have different ideas. So fundamentally, providing more block space is good for like this particular problem, especially if unrelated, like like especially if the fee dimensions and everything are unchanged. Like more block space equals more room equals more capacity equals like fees should go down. Now the issue with subnets in their current form, and a lot of the stuff with teleporter and warp, is like a lot of liquidity is still on the C chain, and bridging it to the subnet without teleporter means having like some sort of custodial bridge. And so in a conversation we were having about this, it's like if you're on the chain and you have the liquidity there, then like yeah, it totally solves the problem. But the issue is that like getting there and like the ecosystem hooking up, everything connected, like some of the concerns around like maybe how the subnet is validated, like what's the staking token of it, all become very reasonable concerns. But in terms of like purely increasing the capacity and maybe even optimizing the EVM more for like storing inscriptions data, it'd be much better for like maybe pursuing optimizations that wouldn't necessarily make sense on a neutral platform like the C chain. But as you mentioned, there's a difference between the technical plane and the social plane, right? If you try to get inscriptors to move to a separate network, like what's to have some other group of people come in and then just start again on the C chain doing the same thing if people have perceived, incremental value of that interaction that's higher than the fee. So like I think it's interesting, and I think it like provides more block space to this activity. And in any world like that, that's what Avalanche is optimizing for. And so like there may be people that are interested in that trade-off, but I'm not sure like it actually fundamentally like discourages people from using the C chain.
I mean, maybe this is an open question for the community. I'd love to hear from Stephen and Aaron as well. Spinning up an iChain is not very difficult. We could, anybody could do that, right? The question is, what are the dynamics of that chain? Who spins it up? What do they set with the tokens, etc. But then the biggest question, of course, is, does it attract users? Will it actually solve the C chain problem? And as Patrick's pointing out, some people might go to the iChain, great, but some other people might very well pop up and fill the emptier blocks now with other inscriptions. So I'm not sure that it's actually a final solution. There are questions in the comments that relate to, aren't inscriptions ERC20s? No, they're not ERC20s. They're lighter weight than an ERC20. So it's just essentially what they are is a mark on the chain without any effect on the final state. So you're just essentially saying Kilroy was here, and that's your inscription. And some indexer outside of the chain is noticing this fact and saying this address made the inscription that Kilroy was there. And now you have the Kilroy was here, inscription in your hand. And then, of course, in the next block, somebody else makes a different inscription. The indexer then gives them credit, etc. Its inscriptions, at some sense, go counter to crypto principles because the state is not being kept by consensus by the validators. It's being kept, they have a different trust assumption. That's why a lot of people are up in arms about them. The trust assumption is that these indexers are external to the chain and they maintain balances. So they're doing something really, really odd to bring their own gas costs down. And in so doing, they end up being able to mint their inscriptions at a substantially lower price than the ERC mint. So I hope that everybody understands that this is one of the key things that makes inscriptions so challenging to address. Go ahead, Stephen.
I do want to comment on that. So even though the per transaction cost is significantly lower for people issuing inscriptions, that does not mean that they are not paying their fair way, right? Like when inscription minters or inscriptors or whatever you call them are hammering the chain with thousands of transactions, they are paying a huge amount of money to get their transactions in. So if you look at the price of, say, an ERC20 swap versus an inscriptions mint, you may say like, oh, like this is clearly mispriced because I'm trying to do the same thing, but they're kind of like circumventing the rules. Well, they're using less capacity in doing so, right? So we actually saw, the reason that the number of transactions being included in the chain is so high right now is because all of the transactions are relatively simple, and so the chain can do more transactions, right? So it's not necessarily that like these things are mispriced per se. It's just a little confusing if you look on like an Explorer on like two transactions side by side and you look at the fee. I did want to go back a little bit to one really interesting point about like the inscription subnet is, one often complaint about subnets is it makes composability harder because you're not able to like actually atomically compose within a single transaction. Inscriptions don't care at all about that. There's no composability at all. In fact, they're very explicitly like losing that ability by just using the call data, not the actual virtual machine. So in some ways, like an inscriptions subnet is almost a really great fit for inscriptions, because I would say one of the major drawbacks of subnet scaling, they've already kind of taken on already, and they're just paying higher fees on the C chain. So as long as there's a market for the validators of that subnet and the users of those inscriptions would be willing to move, then I think that it's actually a great, like those two technologies actually pair really well together, which is a really interesting observation.
One small point there too is like there's an off-chain inscriptions indexer. Like that indexer could be combined with the validator or like the API nodes of that subnet virtual machine, and probably like make it much easier for many people to index that data, which I think is something that benefits inscriptors in general, is like because you're not relying on the state to ensure that verification, that if you do lose data or like there's some blocks that are pruned or removed, having that be part of the same situation may actually be a huge benefit as well, which you're not probably going to be able to like upstream that code into like a layer one blockchain client, but on a subnet virtual machine, which you control as an arbitrary binary, it can probably make a much better experience for people that don't then need to rely on like some single indexer to do everything.
So can we talk a little bit about the design of a hypothetical iChain? Because there's so many benefits to it, and I want everybody to have heard them from this group. So clearly, the iChain could have its own token. Clearly, that token would be used or could be used for staking. That token can be used as gas on that subnet, and that token then has utility to the inscriptors, and suddenly you have token dynamics. So to inscribe, now you got to burn that inscription coin, and this is really
you could even make it a fee too. So like you could actually even pay the validators for storing that data longer term rather than burning the inscriptor token too. That's up to you on a subnet.
This is all great stuff. I don't see any reason why somebody would not create such a subnet with such an associated token. It would be so great. And
the actual virtual machine for it is dead simple as well, because essentially all you need is you need probably some way to like transfer like the gas token, and then you need a transaction to publish data. And they could be in the same transaction. They could be
maybe this could be a really good first case for like the coaxium stuff with the Hyper SDK, because it's like actually pretty built for this, given like the current state of programs on the Hyper SDK, which aren't quite ready. But it would be really good for this.
Is this alpha? Have you dropped the coaxium name in public before? I don't know.
I don't know what you're talking about.
Yeah. Are we dropping alpha? You already dropped the alpha. Might as well describe what it is, Patrick.
So I mean, the Hyper SDK, right? So to preface this, right? This is not avoiding like any issue around scaling like the C chain, X chain, or P chain. It's important as we've developed technology to focus more on like what are the VM agnostic mechanisms that can help scale all the things. Like we shouldn't have to like force people to the subnet to use it. Like we're trying to create mechanisms that could be applied everywhere. So what I'm describing here is something that we are going to roll out first on the Hyper SDK, and then hopefully bring it into the primary network as we like test it out, continue to gain confidence in its capability. And the goal here is, I'm not the first person to mention this, but like there's huge benefits to decoupling state machine replication. So when we're talking blockchains, we're talking state machine replication typically. So you have consensus, so you have data replication, you have consensus, and you have execution. Typically like the three circles people talk about. Some people have called it the trilemma. I'm not going to use that terminology because now we're going to have like 5,000 comments in not the point. But you have these three things you're concerned about. Now, typically in a blockchain, that they're kind of coupled together. So like you may have some pre-consensus mempool where you're like sharing transactions and moving them around in some way. Um, but like that transaction data that you disseminate beforehand is not actually like then used in the block. Typically you then put those transactions in the block, send the block out, come to consensus on that block, and then execute that block. Maybe the execution may even come before the consensus, like you may verify it ahead of time, but it's typically bundled. And so if you wanted to do useful work outside of that bundle, good luck, right? So you're going to be waiting for the next block or your time to produce a block. But let's say, for example, you're collecting a bunch of transactions, whether they be like ordinals, inscriptions, or like actual smart contract implications. You could do useful work there, either like distributing it to the network, finding ways to like somehow sequence it, or even executing it after you agree on that data. Now, I think the first paper that really brought people's attention to like the capability of like decoupled state machine replication was Narwhal Tusk, which a lot of people talked about with great excitement a few years ago. It was something that came out of like the Libra DM research group and then was later adopted by Aptos and SUI. And for the first time, I think people started to think seriously about actually, we don't need to do the traditional way. There are other ways about it. But with any new technology and new way to do it, there are inherent issues that kind of can come up based on how that's actually implemented. So there are different parts of that paper that talk about things that could be done if problems arise related to things like transaction replication or something, where you may try to like, I'm not going to go into some of the details here on like some of the 3 problems that the paper or like the thing that will drop kind of discusses. But the point here is that you want to separate these functions so they can be pipelined without having like this intermediate step. And so what happened is, over the last year and a half, has been working on the Hyper SDK and running all sorts of scaling experiments. We were able to get things up to like tens of thousands of TPS on the Hyper SDK using the traditional like state machine replication model. But at some point, you have this just-in-time problem where like you need to build a block, then push it out to everyone in the network, then everyone else needs to verify it right at that time, and then come to consensus on it. And no matter how performant that like single step is, you can't get around that single step. And so the whole great part of decoupling these things, if you can do it safely, is that you can actually start to do these things at different times or like when you're not doing other things. And so the Hyper SDK is going to introduce this, in the first quarter of next year, fully spec'd out. I'm just working on the paper now for how we're going to approach it. And my bar for like how confident I feel about this is when I present it to Steven, does he immediately like poke a hole in it and say like, what about this? What about that? So this spec has been like a year-long effort of me proposing relatively dumb ideas to Steven, him poking ideas in it, and now finally ending up at a place where it's like, okay, I think that actually might work. So I'm pretty excited about it, but it's really our story for like an Avalanche native, decoupled state machine replication protocol. One of the other differences too is many of those protocols attempt to combine the replication step with consensus. This protocol does not do that. So it can be bolted onto any consensus mechanism, whether that be Snowman or some other network. So it has a little bit more flexibility as well. So people may also be concerned, like, oh, aren't you just taking Narwhal Tusk and adding some sprinkles of sugar on it? No, it's a very different mechanism. It's almost as if you got Narwhal described to you with state machine, like just the replication part, and then just forgot about the rest of the paper and then just went like a totally different way. Not sure what this comment is that popped up on the screen. But yeah, so when we're talking about capacity, it also is important to just reiterate, like we're not waving our hands saying like capacity is going up. We're doing pretty deep research and finding what we think are responsible ways to increase that capacity underneath the same hardware constraints while we're pursuing these fee things. And so I think it's just important to communicate that.
No.
So to come back to inscriptions chain, why this helps, right, is that replication part is really good for inscriptions. You can massively increase the bandwidth, especially if you're targeting very low execution. So you can build a virtual machine that's just hyper optimized for distributing or replicating the data, unrelated to the actual like providing execution capacity. And because there's already multi-dimensional fees, you can then tailor the fee mechanism to limit aggressively execution, but then really make bandwidth usage the primary focus of the VM. So from every metric in terms of like the capacity, like the actual experience, like what the chain is actually optimized for, even on the same hardware, it'd be just dramatically more attractive for interaction, I believe. Sorry to interrupt.
No, it's all good. Aaron, do you want to chime in? You've been unusually quiet.
Sure. Yeah, I think for anybody, I'm unfortunately in a coffee shop between New York and home, which I won't mention where that is, but so I've been a bit quiet today.
Hang on. If anyone can locate where Aaron is and give him a hug, they get what is it? They get 10 Avax. So yeah, there is now a treasure hunt for Aaron. if you're at the coffee house that he's at, go give him a hug. Go ahead, Aaron.
Yeah. I think we can talk for days about all of the optimizations that we're doing in order to create the capability of creating something that makes the best use possible of certain hardware requirements. We can talk about increasing the hardware requirements as well. We can talk a bit about just the economics of this as well, in terms of what would actually attract people to move over to that subnet, which is very important as well. And at the end of the day, this really comes down to the preferences of the people that are creating inscriptions. And these are the people that are paying, $27 million over the past 7 days, I think is the stat that I saw, that is causing, with the current fee model, to the gas prices to go up on the C chain. And so for those people, their preference is that they're actually okay with switching to use a subnet with a slightly different validator set if, that fits perfectly in with their already used trust model, or they already depend on some indexer, such that the fact that they're using the Avalanche C chain, this maximally decentralized validator set, maybe doesn't fully matter to them as much, because the only thing that they're really making use of is sequencing this data in some way. And so if they were to have even just a single node, just their same indexer that's serving that data, they'd end up in a potentially very, very similar point. But what it really comes down to is what their preferences are about what type of system they need to use in order to see whether or not this would make sense for them. And so if it does, if they're actually okay with migrating to a subnet, then all these optimizations start to make a ton of sense. And you can actually see, well, if you just have a more attractive option someplace else, then you'll actually pull those users away from the C chain and bring the C chain back down to lower total usage from inscriptions and get back to the lower fees that we love. And so obviously we want to bring up the maximum capacity of the C chain as well. But in the short term, if they're actually willing or eager to move to a chain where they're going to pay lower fees, or as we've also mentioned, where they might use their own token in order to burn and pay for fees there as well, then you can actually get to a better place much more quickly potentially. And so it really goes into what their motivations are and what they're actually going to care about there, which I think is really important to bring into context too.
Well, one thing I don't know, and that's really going to be the potential fly in this whole ointment, is the value that the inscriptors get from causing havoc on the main chains, right? There is definitely some marketing value from, there's definitely some turning heads value from, essentially everybody, and on any given morning when the fees spike, I look around and I'm like, what is that all about? Which inscription is that? And that gets your name heard. And if that's one of the motivations for inscriptors to mint, and that's one of the reasons why they pay so much to mint themselves, then the iChain idea may not be a good fit for them, because they really want that impact on regular people. They want to make the road more congested. So you stop, slow down, and say, what the hell is that all about? Oh, okay, well, this thing, now your name is heard, and there's no such thing as bad publicity. On the other hand, if they really want a smooth experience, the iChain would be the ideal one. So let me bring up another idea for this group before time runs out. What about the idea of detecting inscriptions and ruling them out? I think I've heard this thrown around. Let's address the crowd on why this may or may not be a good idea.
So I think that there's two kind of things here. Obviously, you're trying to treat the inscriptions differently than other non-inscription transactions, right? So you could introduce this at say the validator level, right? So some people may choose, I want my validator to never build blocks with inscriptions. And you could certainly say, all right, validators, you can play this cat and mouse games with trying to have the validator detect whether or not this transaction is an inscription, and maybe rate limit them or fully block them or things like that. That's kind of one area. And then the other realm, which would be a lot more heavy-handed, would be explicitly like encoding something into the rules of the chain, saying, if you're doing this, then we are going to charge you more. In the actual chain case, it's very hard to kind of fully detect that. So as an example, maybe you say, all right, we require any transaction to have some higher minimum cost that gets put in. So, I was saying before that the Inscriptions transactions are much cheaper than, say, an ERC20 style transaction. So maybe we just say, like, all right, instead of the base requirement being like 21,000 gas, maybe we set like the intrinsic gas transaction to like 50,000 gas or something, and just say, like, all right, like transactions as a whole is going to be more expensive, but if you're using the transactions for computation, then you basically can amortize that, and that is cheaper and is more incentivized. I would be concerned that, the inscriptions, the people issuing inscriptions would take that and say, okay, well, these small transactions aren't good. What I need to do instead of posting a small JSON blob is batch these. So I post like 100 JSON blobs all in a single transaction and say, okay, now all of a sudden I'm actually still paying that same amount, but I kind of get around that rate limit constraint. Additionally, you may say, well, what if we just ban people that are sending like nothing to themselves, right? Because I think that's how the transactions typically look. Well, all of a sudden, maybe they're executing a contract, but still with that same inscription, right? So how you actually detect whether or not a transaction, like within the rules of the chain, is an inscription, ends up being a cat and mouse game. And the unfortunate reality is, if a network upgrade gets planned, at the very minimum, you have to give validators, say, a few weeks at a minimum to be able to update and not get left behind. And in that amount of time, inscriptors can change the rules. They can change what their transactions look like. They can kind of modify their own behavior relatively easily on their side. So I would say it's very hard to like come up with a principled design for filtering out inscriptions on the actual chain rules side. In general, validators control the block that they produce. This is a big thing on Ethereum with like OFAC, like blacklisting of addresses. And so, validators can choose to not include some transactions into their blocks. Whether or not that realistically works from a like game of the validators kind of tuning those configs and making sure that works, I don't know. It is technically an option. I think that if people start doing that, like some people definitely did not like the fact that Ethereum validators were conforming to OFAC. That's a very complex thing. For them, maybe the validators that were conforming to OFAC were concerned about regulations and things like that. This is probably not in concern to any regulations, but more of like an ethos thing. So I think that becomes a very kind of like tough question. And I definitely don't claim to know the answer of, but those are kind of the two areas that I can think of. And I think that we should be really hesitant to try to put anything within the actual rules of the chain, because I think that we'll be playing a cat and mouse game. And also, as far as the chain is concerned, there isn't a huge difference between an inscriptions mint and like an NFT mint. So if we're saying like, oh, if your application is too popular, then like we're gonna try and come up with some way as a community to like disallow that, like it leaves kind of a bad taste in my mouth personally. So yeah.
So let me just, I think we do need to wrap up, but I cannot resist telling a story here, so bear with me. So let's see. In general, let me wrap up the conversation though. So in general, none of us like censorship. Nobody likes high fees. That's true. But also, one of the main things that attracted us into the space was the fact that there is nobody out there making taste and judgment calls on what is good and what isn't good. I think Patrick touched upon this earlier on as well. So one thing that was interesting that came out of the DAO hack on Ethereum was that there are, if you try to do this in the obvious way, if you try to censor transactions in the obvious way, you open yourself up to many more attacks that are far more devastating than inscriptions. Let me tell you one of them. It's kind of funny what happened. So you guys all know about the DAO. You know, maybe you do, maybe you don't. Actually, maybe some of you might not know. The Ethereum had this thing called the DAO on it. It was essentially like a venture fund. Everybody pooled their money into it, and then it could make decisions on which projects to fund. And there's nobody in charge, so you could do all sorts of crazy things with it, right? So it could fund software development projects, but it could also fund, you know, somebody who wants to build a submarine to ferry drugs from Colombia to Florida or what have you. And it was just, you know, it's a fascinating thought experiment, right? So people got very excited, put in a crap ton of money into the DAO. And I wrote a paper that's with two people, Dino Mark and Vlad Zamfir, that said a call for a moratorium on the DAO. This thing is broken at many different levels. And we identified some of the 9 different flaws in it. And the attacker came in and used the reentrancy bug plus one of the bugs that we found in our paper and stole a lot of ETH. And then now what do? Immediately, the community said, well, let's do a soft fork. Let's have the following code that censors all transactions with the DAO. And this sounded like a good idea. In fact, the code was written, it was about to go live. The code was reviewed by everybody in ETH, including Vitalik, including Gav York, including me. And we all thought, yeah, okay, this is a sensible thing. Why not try to identify and filter these transactions? And then this was really funny. I got a message from someone. And that person was a high school student. And it was essentially a message that goes like this. Hey, professor, I'm a high school student. I wrote to you about a year ago, about like 6 months ago, when I was applying to schools. And you helped me out back then. Apparently, I had exchanged messages with him. Very nice fellow. And, you know, I applied to Cornell. I got in. I'm going to be a Cornell freshman. And I was listening to what you were talking about on the DAO. And it struck me that this proposal to censor the DAO transactions, the soft fork to censor the DAO transactions, is full of attack vectors. If you do this, then anyone can submit transactions that are huge, that consume a crap ton of energy, you know, whatever effort to check for validity, and at the very end, they go and touch the DAO. And so at that point, the miner or the whatever, currently would be the validators would have to toss the transaction out. And so I looked at this and I said, oh my God, he's so right. I cannot believe that everybody missed this obvious attack vector. And so we wrote a blog post describing this, saying the soft fork is a bad idea. The soft fork was abandoned. ETH price took a dip. I think it was about a 10% dip. And it's the first and only blog post I've written with a high school student. I'm really proud of it. It was him and his buddy. So it was two high school students and myself who wrote it. And I felt really bad for the 10% dip. I wrote a nice message to Vitalik saying, hey, Vitalik, sorry about it. But, you know, it is what it is. I think, you know, we tried to do the best we could. And Vitalik wrote back a very nice message himself saying, it's not that we lost 10%, we retained 90%. That's the way to look at it. And anyway, then the rest is history. So soft fork was not employed because it would have been a disaster had it been employed. Like ETH would have gone down repeatedly until they undid it. And it would have been a huge, huge disaster. So those all did happen. I'm recalling this just because, you know, this Inscriptors drama can cause a similar thing, and we definitely don't want that to happen. We don't want to be like one of those chains that stopped functioning. We don't want to be doing crazy things that will only lead to, or hurried things that will only lead to worse scenarios. So bear with us. Is this the top of the hour? I think I need to go somewhere at 2:00. So shall we wrap up?
Yeah.
Yeah.
Yeah, I think, you know, I think to just reiterate, because I saw some comments from people that joined later or didn't hear any previous part of it. There's a number of things that we're focusing on as the Avalanche development team to increase the efficiency of Avalanche Go and or introduce new mechanisms to alleviate high fees, which the community has been clear that we prefer, you know, increasing capacity and lower fees rather than driving up burn of Avalanche, the token. Now, the two ways to do that are, one, increase capacity across a number of different resources. The second way is improve the metering to better take advantage of the resources we already have. So the latter, I said it in the wrong order, increasing the usage, like increasing the efficiency of the resources we already have or the usage of them, is the first thing that we're targeting. So we're going to try and find some way to better price how people are interacting with the EVM so that we can independently price things, because regardless of what capacity is introduced to the C chain, whether that be like higher validator fees or anything like that, you have to better take care of that capacity to avoid different attacks. So our focus is on that, and that should increase the capacity for bandwidth usage on the primary network, particularly in the C chain. And then on top of that, then it's coming into the capacity of what those limits are and increasing that capacity through a number of other things we're targeting. So what I talked about was coaxium on the data and bandwidth layer, and somewhat on the execution layer. In terms of state management, we're trying to increase capacity through the introduction of Firewood and novel databases. So two things: better use the capacity that already exists and better meter for it. And then the other side is actually increase that capacity once it's better metered. So you can't decouple the two. Those are the two things we're pursuing, and with immediate effect, at least what we're going to try and propose as an ACP in terms of adjusting the fee mechanism to better take advantage of that, using some of the stuff we've learned with HyperSDK multidimensional fees. So that's what we believe is the most principled approach to actually increasing the accessibility of the C chain.
Let me add a few more things. So this is the discussion with the platform, with a couple of the members of the platform team from Ava Labs. So there is a far bigger push, and everything is on the table, and so we only focused on the platform side of things because that's where the fundamental issues really lie. But there are also things you could do at the periphery. So one of the things that we have to do at the periphery that you can expect to see very, very shortly is in communicating what's going on with the fees. I think a lot of people are being freaked out by the fees reported in the core wallet. So when it says this fee is going to be, let's say, $2.50, that's up to $2.50. It's often the case that it's giving you a conservative estimate, and your actual fee paid is a lot lower than that. So keep that in mind. We're going to change the messaging around this immediately so people are not confused. Even I did not realize this. I was just using this thing and I thought that was going to be the fee I paid. It's up to, and often I pay less. So that's one. And then the other thing, of course, is that fee estimation mechanisms, etc., if implemented badly, might interact with each other badly so as to drive and ratchet up the fees in the presence of congestion. This is a well-known effect. This happened on Bitcoin. And I don't think the mechanisms that we have are subject to ratchet effects. I don't think that they are bad in any sense of the word. But I wonder if there are better things one could do. So that's also something on the table that we are looking at. So these are things that are outside of the core code, but it is in the wallet code. It's at the periphery, and it might end up impacting how the network behaves in its emergent fashion. So I hope that was useful for everyone, and I hope you get a couple of messages out from all of that discussion. One, and maybe the only message that's really important here, is we're all on it. We hear you. We're on top of it. We are doing everything we can, no holds barred, to address the high fees issue in the presence of inscriptions. We will only do those things that we are confident fundamentally attack the problem at its core, and we've identified a set of these things. Some are easier than others. Some will take less time. Some will take slightly more time. But rest assured that we're working on it. If history is any guideline at all, we've had issues before related to fees. We've had spikes before. We've addressed each and every one of them in time. We have brought the most tech to this space. We have brought the best tech into this space. We're not just a bunch of people who bring slight bits of engineering and duct tape and glue. We actually fundamentally build things in a different fashion to address the problems at their core. So bear with us as we deal with the inscription craziness, and we will do whatever is scientifically possible to get back to the low fees that we know and love from Avalanche. So thank you all very, very much for bearing with us. And we'll keep everybody abreast of what's going on. There's going to be a lot more discussion on this topic, and there'll be ACPs coming out. There'll be code updates coming out, and there will be changes coming out. And it's these things are great in many senses. This is the time to sort of sort out the congestion issues. This is the time to deal with the load that they pose. This is the time to get all the algorithms in place so that when we are in the big leagues, when the space is exploding again above the trillion level, etc., then we are fully ready to take on those loads. So thank you again.
Thanks, everybody.